All right, so let's talk about factoring trinomials when we have a coefficient, a leading coefficient that's greater than 1. Okay, so I'm quickly going to go through the steps and jump right into the actual problems. You're going to put this in descending order, and then you're going to multiply the first and the last terms. This is going to be the product that you need. The coefficient of the middle term will be the sum. Remember, when the coefficient equals 1, we used what was called the product sum. So there's your product and there's your sum. The difference here is the product will have some other factor besides 1 in the front. So we're going to find the two numbers that give the product and sum. You're going to rewrite the trinomial with 4 terms. You split apart the middle term. So a lot of the teachers I know, they call this split the middle. So that's what you're going to do here. Then you're going to factor by grouping, and remember that last step that I always write in by myself is check by multiplying. Excuse me. Okay, so we have 3x squared times 8x plus 5. So we do what it says to do, multiply the first term times the last term. We're going to need two numbers that multiply to make 15x squared, but at the same time, they need to add to 8x, this middle term. So think about what they are. Some of you know right away that it's going to be 3x and 5x. 3x times 5x equals 15x squared. 3x plus 5x equals 8x. I'm going to zoom in just a touch. Bear with me here. This is all new to me. There we go. So we've multiplied the first and the last. We found the sum. We found the two numbers that will give us the product and the sum. You're going to rewrite this term into 4 terms. Rewrite the trinomial into 4 terms. So we bring down 3x squared. 8x is going to be 3x plus 5x, and then we bring over our plus 5. Now we're going to factor by grouping. So what's the greatest common factor of 3x squared and 3x? 3x. When we divide that out, we're left with x plus 1. What's the greatest common factor of 5x plus 5? 5. When we factor that out, we're left with x plus 1. And again, from the previous lesson, we noticed that we have an x plus 1 in common. And then we have the leftover of 3x plus 5. All right. I don't like that row, dear. I want to do the box. That's fine. Let's do the box then. I'm going to use these 4 terms. Remember, we need 4 terms because there are 4 spaces here. So we've got 3x squared plus 3x plus 5x plus 5. And remember, there's a little way to check this. 3x squared times 5 gives me 15x squared. 3x times 5x gives me 15x squared. I know that these are the right numbers to use, and I know that every term is in its proper position because I have the equal cross products. What's the greatest common factor of 3x squared and 5x? It's just an x. What's the greatest common factor of 3x and 5? 1. Now let's look at the rows. What's the greatest common factor of 3x squared and 3x? 3x. What's the greatest common factor of 5x and 5? That's a 5. So this factors to 3x plus 5 times x plus 1. And you know, if you do the box method, it does check itself for you. It really does. What is 3x times x? 3x squared. What's 3x times 1? 3x. What's 5 times x? 5x. What's 5 times 1? 5. Check. It all checks. And then when we combine these like terms, we get our original trinomial. This is why I love math. This is why I spend all those months at the beginning going over this stuff with you, because this right here, ooh, is my favorite stuff. This is what I want to teach kids for the rest of my life. It's just how much fun it is to me. All right, we want to factor 7a squared plus 3. Let's try to multiply 7a squared times 3. When we multiply that, we will get 21a squared. And then we need the numbers to add to 22a. All right, so you might say, okay, well, 3 times 7 is 21, but that only adds to 10. There's nothing else, Robadeer. Ah, but there is. Remember, 1 is always a factor. And in fact, that's the one that I always do first. I know it sounds crazy, but I always have to make a list. I'm actually writing on yesterday's video notes. So remember here how I made my little list? I'm doing the same thing. I have to have everything organized because if it's not organized, I am a hot mess. And this is one of those instances where that happens. So this is the pair of numbers that I want. So we're going to rewrite this as 7a squared plus 1a. The 1 is optional, guys, remember? Plus 21a plus 3. So we look at these two and we see the greatest common factor is a. We're left with 7a plus 1. We look at these two. The common factor is 3. We're left with 7a plus 1. And now I notice I have a common binomial factor of 7a plus 1. So I'm going to take that out here. And then I look at what's left over. And I'm left with a plus 3. And I'm almost sure that's right. But remember, I'm extra. I admit it. I'm going to do this just for those of you that prefer the box method. All right, so let's look at what they have here. My terms are 7a squared plus 1a plus 21a plus 3. Okay, the greatest common factor here is 7a. The greatest common factor here is 1. In this row, the greatest common factor is a, and in this row, the greatest common factor is 3. So my final answer is going to be a plus 3 times 7a plus 1. And there it is. Same thing. It's the same thing I got when I factored by grouping over here, which is nice. And again, I can check it. A times 7a is 7a squared. Check. A times 1 is 1a. 3 times 7a is 21a. 3 times 1 is 3. Boom. There it is. All right. Let's look at example 3. I want to multiply 2y squared times 15. So my magic product here is going to be 30y squared. And yesterday I didn't use the variables, or I beg your pardon, on the previous lesson, I did not use the variables, but I need them here because how else can I make y squared? And I want to make sure that I've got everything covered. All right. So I notice here that I've got a positive product, but I have a negative sum. So because this is positive, both of these have to be the same. They have to have the same sign. Oh, Rona, is that you? I apologize. Now, these have the same sign because they multiply to a positive product. Both of these numbers, when they add, they make a negative number. So that means both numbers must be negative. So let's make sure we do that. So I've got negative 1y times negative 30y. That adds to negative 31y. I've got negative 2y times negative 15y. That adds to negative 17y. Excuse me. I've got negative 3y and negative 10y. That adds to negative 13y. Ding, ding, ding. There it is. That's the one that I want. Okay, that one. So let's break this up into 4 parts. You know what? I'm going to jump right into the box on this one just so you can see it. Okay. Let's see here. I've got 2y squared as my first term, and I'll go ahead and put the plus 15 down here. And the two numbers that fill in this diagonal are negative 3y and negative 10y. Let's look at greatest common factors. 2y squared and negative 10y have a greatest common factor of 2y. Negative 3y and 15 have a greatest common factor of 3, but remember, the sign that's on top floats up with it. The greatest common factor of 2y squared and negative 3y is y. And then the greatest common factor of negative 10y and 15 is 5, but again, this negative floats out. So my final answer is y minus 5 times 2y minus 3. All right, are you getting the hang of it? Fabulous. I'm going to leave number 4 for you to do, but it's also in the filled in notes. Let's look at number 5 because, oh, just kidding. Let's look at number 4 because that's where I've got 2 different variables, and this is really what I want you to see. Let's multiply 3x squared times negative 8y squared. So we need 2 numbers that multiply to negative 24 x squared y squared. And at the same time, those numbers need to add to negative 10xy. The negative sign here tells me that these numbers have to have opposite signs. And this tells me that the bigger number is negative. All right, so let me start putting together my opposite signs. I've got 1xy and I've got 24xy. Oh, negative 24xy. Dude, I almost messed that up. When we add these, we get negative 23xy. I've got 2xy and I've got negative 12xy. That adds to negative 9xy. I've got 3xy and negative 8xy. That adds to negative 5xy. And I've done something wrong because I've passed the negative 10. Oh gosh, I did. What is 2 minus 12? Dude, it's negative 10. Ding, ding. There it is. So this record of me messing up is forever because, you know, everything is forever on the internet. So, you know, sorry about that, guys. All right. So we're going to break this up as 3x squared plus 2xy minus 12xy minus 8y squared. So that's how this breaks up. So let's put these two together. We have a greatest common factor of x. We're left with 3x plus 2y. Oh, dang. Let's put these two together. We're going to take out a negative. The greatest common factor of 12 and 8 is 4. The greatest common factor of xy and y squared is y. We're left with 3x plus 2y. Oh, would you look at that? So I've got this binomial that's the same in both of them. And then I've got the x minus 4y that's left over. And that goes there. All right, let's look at this one in the box. I have my 4 terms. I probably should have made more room. Excuse me. Sorry, the weather change. My terms are 3x squared plus 2xy minus 12xy minus 8y squared. All right, the greatest common factor of 3x squared and negative 12xy is 3x. The greatest common factor of 2xy and negative 8y squared is 2y. Now let's look at the rows. The greatest common factor of 3x squared and 2xy is x. The greatest common factor of negative 12xy and negative 8y squared is negative 4y. So my final answer is going to be x minus 4y times 3x plus 2y. And that's the same answer that I got using the other way. Okay. So for a lot of you, you may not even need to make a list. For example, remember now, I've been doing algebra longer than you've been alive. Oh my goodness, I've been doing algebra longer than some of your parents have been alive, I think. So what happens here is I can look at this and say, okay, 6 times 10 is 60. What multiplies to 60 and adds to 19? I know that those numbers are 4 and 5, and I can run with that. But to get the binomial, that I don't know. When I grew up, back in my day, before the internet and before all that good stuff, we had to do this by trial and error. So it was guess and check. 6m squared could be 3m times 2m. Oh, or it could be 6m times 1m. And then you would say, okay, to make 10, we do 2 times 5. Oh, and then you FOIL it and you realize it doesn't work. So then you flip it. Oh, maybe it's 5 times 2. Nah, bro, we don't do this anymore. We're going to do split the middle. I would rewrite this as 6m squared. Remember I said it's 15 times 4. So 15mn plus 4mn plus 10n squared. And again, do this. It's in the notes, but just to kind of keep you from listening to me drone on forever, I'm going to kind of knock this one out. The greatest common factor here is 3m, and I'm left with 2m plus 5n. When I look at these two, the greatest common factor is 2n. I'm left with 2m plus 5n. And then I see that I get 3m plus 2n times 2m plus 5n. There it is. All right. And again, you could do the box, and again, it's on the notes. Let's look at number 6, because, you know, this is what it's all about. I have to give you an example that doesn't work. Oh, I just ruined it for you. Okay. We're going to multiply 12r squared times 3s squared. So please think of two numbers that multiply to 36r squared s squared. And at the same time, they add to negative 11rs. These numbers have to have the same sign, and the bigger number has to be negative. Just kidding. They're the same sign. So that means that they're both negative. Oh my gosh. I can tell it's Whew. All right, here we go. So what multiplies to 36? Well, we have 1 RS times 36 RS. Negatives, come on, Robodeer. When we add that, we get negative 37 RS. Let's look at negative 2 RS and negative 18 RS. That adds to negative 20 RS. We have negative 3 RS and negative 10 RS, which adds to negative 13 RS. All right, we're getting closer. We have negative 4 RS times negative 9 RS. That also adds to negative 13 RS. Oh, my bad. This is 12. So this becomes 15. Oi. Oh my gosh. There's so much evidence here that Robodeer is having a moment. So the only other way to make 36 is to take negative 6 times negative 6. That adds to negative 12 RS. Is there anything left? I could go to 7, but remember whenever you did this in 6th grade, you would say 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Well, then 7, 8, 9, well, we've exhausted all of the possible pairs. Is there a pair of numbers that multiplies to 36, but at the same time adds to negative 11? No. So guess what? This is not factorable. I always have to show you one example where not all the cases work, and this is it. All right, so there's your video. Now work on the ICC if you would, and we're good. I'll figure this out in a second, guys.